Hello. For my lab, I will be analyzing the motion of the moon orbiting the Earth. For this lab, I am using Newton's second law to create a computational model. Before I can write my code, I need some initial data. First of all, I found the mass of the Earth to be 5.97 e to the 24th kilograms. I found the delta t of 1 day, or 86,400 seconds. I set the Earth's initial position to the origin, or 000, and I found the distance from the moon to be 3.84 e to the 5 kilometers. I found the mass of the moon, 7.34 e to the 22 kilograms. I used a time step of 27 days, which is one orbit of the moon. I also need to know some initial formulas. Here we have Newton's second law, where Fnet is equal to dp over dt. dp over dt is equal to mass times change in velocity over change in time. Here we can separate these into a perpendicular and parallel components. We also need to know Newton's law of gravitation, which is gravitational constant times mass of the Earth times mass of the moon divided by the distance in between squared. Here g is equal to 6.7 e to the negative 11th. For my code, I based it off the black hole lab that we did earlier in the class. First of all, I had to set initial conditions, which was the Earth's mass, the delta t, which is 86,400 seconds, and I had to import my own moon data Excel file. And this is where I found the position of the moon at each day. As we scroll down, we see where I imported Newton's second law. Here I found the Fnet, and I split this up into Fnet parallel and Fnet perpendicular. Scroll down more, we see where I imported Newton's gravitational law. Here I used the gravitational constant, the Earth's position, and I found r from these two data points, Earth's position and the moon's position. After you hit run module, this is the module that we get. Here we see the Earth positioned in the center, and the black sphere is the moon orbiting the Earth. So putting it all together, we found that almost any physics concept has the ability to be modeled. If taken one step further, I would have been able to model the solar system if given the essential masses and initial distances. Although my lab was similar to the black hole lab, I knew the initial masses and manually found the different positions, instead of knowing the positions and finding the end mass. Also, when trying to create your own model, always start from a fundamental principle. Thank you.